Hi, welcome back. Moving on with stoichiometry, let's go ahead and investigate or find out what a limiting reagent is and what a yield is. Essentially, a limiting reagent is the reagent that will run out first, and a yield is the mass of the predicted value from the stoichiometry. So if you're given a generic equation where this represents a balanced chemical equation, and what do if you have two masses that are given? You need to find the limiting reagent and then use the limiting reagent to do your stoichiometry and predict your yield or the mass of either another reagent or another product. So you'll use the given mass and predict the number of moles for each of the reagents given. Let's say you have X moles of A, which you calculated from some given mass, and Y moles of B calculated from some given mass. What you will do then is to cover one of them. It doesn't matter which one you cover. You can either cover Y or X. And the one that you have not covered, use that to predict the theoretically required moles of the other reagent. So you can use X to predict of how many moles of B you will need. And you already know that you are given Y moles of B. Once you have the answer predicted from your stoichiometry and the mole ratio, which I cover in another video, you want to uncover the amount that they gave you, and you know they gave you Y moles because you calculated from the given value. And then compare how much is required against how much is given. Let's go ahead and use a real example. Titanium, which is used to make airplane engines and frames, can be obtained from titanium tetrachloride, which in turn is obtained from titanium dioxide by the following process. So you have titanium dioxide combined with carbon and chlorine, and you produce titanium tetrachloride, carbon dioxide, and carbon monoxide. And you are given a balanced chemical equation, which is really nice. You have a vessel that contains 4.1 grams of titanium dioxide, so that's a given. 5.67 grams of carbon, so that's given. And 6.78 grams of chlorine, and that's given. And suppose the reaction goes to completion as written, how many grams of titanium chloride can be produced? So we will again, according to our procedure we learned in our stoichiometry video, we will put a question mark on this one. Now you suddenly realize you don't know where to start. You have to figure out the limiting reagent of these before you know how to proceed with calculating the mass of titanium chloride. As I said before, each of the masses have to be converted into moles. Using the molar mass, we convert the titanium dioxide and we get 0.0519 moles. For carbon, dividing by 12, we'll get 0.4725 moles of carbon from 5.67 grams, and 6.78 grams of chlorine dividing by 70.90 will give me 0.0956 moles of chlorine. So from all of these given masses, I was able to figure out the number of moles of each. Now again, I will choose one to predict the moles of the other two. I chose carbon. So 4.725 moles of carbon, let's say I had 4.725 moles of carbon, theoretically, how many moles of titanium dioxide would I need? And it is question mark coefficient of what you need over the coefficient of where you started out. So you know I will have to multiply this number by 3/4 because we need some information on titanium oxide. So if you pretend that carbon is given and you're asking questions about titanium dioxide, you will go 3/4. And my final answer is that I predict if I had 0.4725 moles of carbon, we predict that we will need 0.354 moles of titanium dioxide. We're actually given 0.0519 and we need that much, so we immediately know that we're short. So the given value is less than the predicted value. So we will call this a limiting reagent. By the same token, they gave me 0.0956 moles of chlorine, and I need 0.709. So again, chlorine is also our limiting reagent. We cannot have two limiting reagents. We cannot have chlorine and titanium dioxide as limiting reagent. We already know that carbon isn't. So between titanium dioxide and chlorine, you can pick either one of these, and I picked titanium dioxide to predict theoretically from 0.0519 moles of titanium dioxide, I will need twice as much chlorine. So I will predict 0.1038 moles of chlorine if I had 0.0519 moles of titanium dioxide. I looked to see how much chlorine was given. Not enough. So chlorine will run out first, and chlorine is my limiting reagent. Now I have a given, and I can use my standard procedure to predict the mass of titanium tetrachloride. Starting out with the mass of chlorine, going from mass to moles of chlorine, I divide by the molar mass of chlorine. Then I multiply by 3/6. It is the coefficient of the question mark over the coefficient of the given. And then going up, I need to multiply by the mole of the titanium chloride. And my final answer is 9.01 grams of titanium chloride. Now, if you wanted to calculate the percent yield, the actual yield is what will always be given in the question, and what we just calculated was the theoretical yield. So the formula for percent yield is simply actual yield divided by the theoretical yield times 100/1. The theoretical one is what we theoretically calculate using our rectangular box system we learned in the stoichiometry video. So this ends this session. All I wanted to talk about here was that if you have several given masses, you need to calculate the moles of each and use the moles given to predict theoretically by the mole ratio of the balanced chemical equation the expected moles, and then compare with the given mole and see if it's limiting reagent or whether it's an excess. Thanks for listening. Goodbye.